Welcome everybody, I'm Tim Lenton, here to offer you a very warm welcome to the University of Exeter and the conference. That was, as you saw, a data-driven light and sound installation from the Greek artist Yannis Kaloidiotis, who is over there. Well done, Yannis. Woo! And if you want to see the longer version, over a drink this evening when we have the 5 p.m. Social, just come back in here. Yannis will be here to talk about the work. You can see the full-length version later. And I think just the short version gave us all a little visceral introduction to tipping points. I'm here to welcome you also on behalf of our partners, organizations, and my co-conveners. So Johan Rockström from the Potsdam Institute for Climate Impact Research and his team, and Ricarda Winkelmann from the Max Planck Institute for Geoanthropology. And you'll meet both of them very soon on the first panel. I also need to thank our sponsors, of course. Otherwise we wouldn't be here having this, what I think will be an amazing meeting. So that's the Bezos Earth Fund, ARIA, the Advanced Research and Invention Agency, TREX, that's Transition Risk Exeter Limited, the World Climate Research Programme, CORDIO Climate Foundation, the Global Challenges Foundation, and WWF, the World Wildlife Fund. And I also want to say straight off the bat a thank you to the amazing organising team behind this, especially Chief Organiser Hattie Hopkinson, wherever you're hiding, sorting the furniture. Woo. And a thanks in advance to all of you who flocked here, sold the event out, and brought a host of, ideas and activism, and proposed something like 50 research sessions and action workshops that we're going to enjoy together in the next few days. Now, before I say a few more words about the program, the necessary housekeeping, so you can all read the slide, but the key point is, if the fire alarm goes off, I think the noise will be obvious. If we're in here, you can follow the directions outside from the fire marshals. But basically, the fire exits are at either side of the big open street we were just having lunch in outside. And if you happen to be up on the first floor in one of the seminar rooms, the fire exits will take you to the easiest stairs to get down that are in the top corner, or the lift to get down up there. Okay, so I just wanted to introduce a little bit the journey of the conference before we get stuck in. If some of you came to the first Tipping Points conference in 2022, you'll see some familiarity. But essentially, this is about going from wrestling with some of the most, if not the most profound risks we face in a changing climate of crossing Earth system tipping points and unpacking what those risks are, through to what I would view as the only credible way out of trouble now, which is we need to radically accelerate action, which means we need to find and trigger what I call positive tipping points that can create the self-propelling change in behaviours and technologies to a zero emissions and much happier, healthier future. And in the middle of all that is how on earth do we govern our way through some of the unavoidable risks that are going to come, as well as how do we govern the extraordinary, very rapid transformation we need to get out of trouble. So allow me to indulge the theme a little bit. Here's a movie some of you have seen before where we're forcing a system towards a tipping point. It's got those two alternative stable states. The one on the left is the one it's in, but we're making the system less stable over time, and that initial state is losing resilience. The damping feedbacks that maintain the old status quo are getting weaker, and at some point the amplifying feedbacks within the system are going to get so strong they take over, and they're able to support a self-propelling change from one state of a system to the other. Now that could be, and you see it's once it gets going, it's self-propelling, it's very hard to reverse, and it could be quite abrupt. That could be a bad tipping point in the climate or a positive one in societies and technologies, and we're going to be covering both. But if I just start on the Earth system risks, it feels strange for me because it's sort of 20 years I've been raising the red flag on these risks. I felt like the lone, or one of a very few canaries in the coal mine with a few of you 20 years ago. Now, hundreds of you here are flocking to hear more about this. This was our assessment in 2022 of some of the big parts of the Earth system that were at risk to tipping elements and how close might the tipping point be. I suppose part of the tragedy here in 2025 is we're no longer at 1.1 degrees C roughly of warming. I put it at 1.35 and we'll be at 1.5 in 2030 at the current rate. Meanwhile, although there's some uncertainty around various burning ember risk assessments, well, we already knew a few years ago that we were well into the danger zone for multiple systems. You can read them off, I could reel them off, including the coral reefs that hundreds of millions of people depend on for their livelihoods. But I put a couple of yellow arrows on because the last 3 years of science have certainly changed some of our risk assessment, and sadly, for some of the biggest risks, including the Amazon rainforest and the great overturning circulation of the Atlantic Ocean, we would definitely put their tipping points closer to the present temperature. And whilst we all enjoy a heat wave, I hope, this week in Devon, if we were to cross a tipping point in the Atlantic Meridional Overturning Circulation, or AMOC as it's called, things would look rather different here. And sorry to be parochial for our international visitors, we would still actually be having summer heat waves that would barely feel any different. In fact, in the backdrop here, which is a 2 degrees C warmer world, there'll be worse heat waves than the one we might be about to enjoy this week. But I'm afraid the winters, which is what is pictured here in a recent study, would look very different. So just to give you a feel for what a particular tipping point looks like, on the right, you're seeing where does the sea ice now extend in the depths of winter in the Atlantic through December in black, January in blue, and by the time it gets to February, we've had a tipping point in the AMOC. Despite being in a warmer world, we've got the sea ice wrapping around much of Great Britain. And on the left, you see what in the contours, you're seeing what a decadal climate extreme looks like in that changed climate. It's something like 30 degrees centigrade colder in Edinburgh, or 20 degrees centigrade colder in the extreme in London or here. It would be an absolutely extraordinary, complete transformation of the seasonality and the nature of the climate, not just for the UK, but for a lot of Europe. And I would propose we would struggle to cope and adapt to that. So that's just a sense of the risks we're running, and we're going to unpack that a lot more, well, particularly today, because the journey of the conference is today we're going to dwell on those Earth system tipping point risks. Tomorrow we're going to unpack, okay, well, what are the societal implications if we cross tipping points in the climate or in our life support system, in the ecosystems and the biosphere we depend upon? And then how on earth do we govern in the face of risks like that if they start to unfold? Or indeed, how do we govern to avoid them? But then we're going to flip the script partway through the meeting. So when we get to Wednesday, we're going to turn our attention to the positive tipping points. The evidence that, in fact, there are also good tipping points, the tipping points we need to change faster, to decarbonize the global economy. Now we need it to go at more than 5 times faster. And yes, I've spent a lot of the last 2.5, 3 years since we held the first meeting writing a book about this that will come out in September, and really kind of trying to give myself what my friend Simon Sharp, who's probably here, calls plausible grounds for hope, that there is a credible case we could accelerate out of trouble by finding the stories and the evidence that we are already seeing self-propelling, accelerating change in some key sectors and activities, like to electric vehicles in Norway, or the shutting down of coal burning for electricity generation in the UK, or now in the global picture, the extraordinary uptake of solar PV, solar power. Now, the toy model is the same. We know we're in an unsustainable state of society. We can vision and imagine and know that there's another sustainable, flourishing state for all of us in our economies. And we see in some of the historical recent examples the actions by diverse actors, policymakers through to bottom-up civil society activists, that can sometimes destabilize the incumbent regime and ultimately help shift the balance of feedback in a system so that the amplifying feedbacks that can support self-propelling change get strong enough to create a tipping point where, for example, the more solar panels we've bought and installed, the better they've got and the cheaper they've got. So that now, in the case of solar power, as a colleague Femke Neisser and others showed, it's already the cheapest form of electricity in the world when you factor in the cost of also battery storage for renewables. And it's getting cheaper faster than anything else. So we're rapidly heading into an amazing future of cheaper electricity than we've ever known, coming from solar, to some degree wind and battery storage. A huge opportunity for all of us, especially that, well, you could say especially the 80% of the world's population that live in net fossil fuel importing countries, or the 700 million people that still don't have access to electricity. So as we go into the positive tipping points, we'll be unpacking those social technological ones, but we also have a session on the positive potential for positive tipping points in nature. Well, I'm working myself on this at the moment, and so I started trying to make a map to go with my map of all the bad tipping points, which I'm sure you know well. Maybe we come out of the conference with a better map of the instances of positive tipping points. In this case, a few examples of where communities have come together to positively tip change in their ecosystems, their life support system. Because if you can tip the degradation of an ecosystem, it might take more work to tip it back, but it's still possible in principle to positively tip it back. And that's something we want to explore together. And then how do we govern, as I said, all of this? And so my closing thought before I hand the chair over is I'm sure as we wrestle with governance, we may all have the scales of justice in our mind. What can you say there? I mean, the scales are very uneven, as in the picture here, because hundreds of millions of people are already on the bad side of the scales, suffering the harms of escalating climate change. At the same time, we don't want to create new harms in creating an abrupt transformation to get out of trouble. But if we are wrestling with those questions, I think we have to remember how many people are on each side of the scales. And I suppose, for me, the art of good governance is not to create gratuitously new harms for anybody in transforming everything as fast as we can, but always remember how many people we could, and we're among them, who we could lift out of harm that's coming inevitably otherwise if we carry on the way we're going with the Earth system tipping point risks. Oh, and remember, of course, all the benefits that have come when we make this great transformation. So yes, welcome again from me. And at this point, we're going to get cracking on the program and focus in the first panel with the Earth system tipping points and risks. And I just want to introduce the chair for that panel. So Bette Otto-Bliesner is going to take over from me. Bette's a senior scientist in the Climate and Global Dynamics Laboratory at the NSF National Centre for Atmospheric Research. And I've known Bette's work for, decades now, because as I started mapping out tipping points, Bette was one of the lead researchers on modelling past climate tipping points, and has also been a key part of the team that's built what's called the Community Earth System Model, one of the state-of-the-art models that, in fact, you saw some results from a minute ago. And Bette's also the co-lead for something called the high-risk theme in the World Climate Research Programme's Safe Landing Climate Lighthouse activity, it's called, and part of what we'll hear more about in the next few days, which is something called the Tipping Point Model into Comparison project that many of us are engaged in. So thank you all for being here. With that, I'll hand the stage to Bette to get us started.
So thanks, Tim, for setting the stage on this Global Tipping Points Conference 2025. And I just found out, just before I started, that congratulations, Tim. He's been appointed to the Officer of the British Empire. And so... And so if you want to read more, Google it. I didn't get a chance to look at the full citation. So today we have 4 exceptional scientists who will be giving presentations and then answering your questions. And so I just want to tell you a little bit about each of them before we start. So Dr. Carlos Nobre, over there, okay. Oh, he's already up here, okay. As an Earth scientist, system scientist from the University of Sao Paulo in Brazil, he's co-chair of the science panel for the Amazon and one of the architects of the large-scale biosphere-atmosphere project in Amazonia. Carlos conceptualized the Amazonian 4.0 project, which aims to develop a new nature-based bioeconomy. Then we have Dr. David Obura. He's chair of the Intergovernmental Platform on Biodiversity and Ecosystem Service, IPBES, and founding director of CORDIO East Africa. He studied coral reef resilience, biogeography, and climate change impacts, and regional approaches to sustaining marine and coastal ecosystems. And he is combining now understanding of Earth system science and interactions between nature and people to strengthen the then scientific underpinnings of sustainable development. Professor Dr. Ricarda Winkelmann. Ricarda is founding director of the Max Planck Institute of Geoanthropology and the Earth Resilience Science Unit Chair at Potsdam Institute for Climate Impact Research. She specializes in fields of climate physics, mathematics, and Earth system science, contributing to the understanding of the Greenland and Arctic ice dynamics, past and future sea level change, ecosystem resilience, and tipping dynamics. And she initiated and leads the Tipping Point Modeling Intercomparison Project, or TIPMIP, that you'll hear a lot about during this conference. And then, last but not least, Johan Rockström, who's director of the Potsdam Institute for Climate Impact Research. He's an internationally recognized science on global sustainability and Earth resilience. He led the development of the Planetary Boundaries Framework for Human Development in the current era of rapid climate change, and is deeply involved in research on the future trajectory of the Anthropocene and future tipping points. He is also a leading scientist on global water resources. Thank you. So we'll start out here with each of the speakers giving us a kind of a brief, about a 10-minute presentation on present state of the research and the risks associated with Earth system tipping points. We'll save all questions until after all four have spoken, and then there'll be microphones on each side of the room, and we'd like to hear your questions for them either individually or to the panel. My only request is, with so many people here and so many interesting, I'm sure, questions, please, when you come up to the microphone, state your name and your institution or affiliation, and try to keep your questions succinct so that we have plenty of time for the answers. So our first speaker today will be Johan.
Thanks, Bette, and it is wonderful to be here and to see such a full auditorium on the second Tipping Point conference. It just shows what enormous momentum it is to understand the functioning of the Earth system, the risks we're taking on destabilizing potentially life support at the Earth system level. And what I want to do in the next 10 minutes is, based on the science we have, kind of challenge ourselves in how should we think and how should we communicate about risk and about Earth resilience in the future. Now, as Tim pointed out, we've come a long way scientifically. This is an Earth system illustration of the 16 climate tipping elements that we now have documented. They're all in the IPCC AR6. The Arctic is what I call a ground zero, with 6 of the tipping element systems connected via the North Atlantic, but also with biomes like the Amazon rainforest all the way down to Antarctica. These are biophysical systems, both biotic and abiotic, regulating the functioning, the stability, and the resilience of the entire Earth system. We also have more and more science, and sessions will be held this week on looking at cascade risks between these systems, and it's quite clear from the scientific evidence we have today that we have kind of 3 key nodes of the Earth system, the Arctic, the Atlantic, or the ocean conveyor belt that connects all systems on planet Earth, and Antarctica, and that these are intertwined and that we cannot separate one from the other. Today, we call these planetary commons. This is something which I think is one of the avenues for a transition towards a safe operating space to legally define these tipping element systems as collective responsibilities for all nations on planet Earth. What does this mean, the scientific burning embers assessment on all the tipping elements in terms of risk and in terms of resilience? I think it's time to be courageous here, to step out of our comfort zone and actually to start communicating the risks level in a bit more succinct way. Why? Well, it's because we are increasingly understanding that it's not only the climate forcing that drives the risks of pushing systems across thresholds, it's all the planetary boundaries that defines the stability of these tipping element systems. So we have the biosphere boundaries on biosphere integrity, land system change, changes of the bloodstream of the Earth system, the hydrological cycle, overloading of aerosols, pollutants, but also nitrogen and phosphorus fluxes. All of them are today assessed to be outside of the safe operating space of an Earth system able to stay within a Holocene interglacial equilibrium state. So it's not so surprising that we have findings like this, that the Amazon basin is assessed in the climate tipping element assessment, the McKay et al. That we just showed from 2022, that the risks may be somewhere around 3 to 5 degrees Celsius of global mean surface temperature rise, which Carlos Nobre will be showing very soon is not scientifically founded in evidence, because transgressing the other boundaries on biosphere integrity, on land system change, deforestation, and shifts in moisture feedbacks changes that whole risk level and lowers down the temperature down to the range, as Tim pointed out, where we're heading towards within the next just 5 to 10 years. This is a very, very dire insight that we have to take a whole Earth system approach even to assess the stability of the climate tipping element systems. Is this a completely new finding? Well, actually, the trajectory of the IPCC assessment show very clearly it isn't. From the third assessment in 2001 until today, the assessment of risks of crossing tipping elements defined here as singular large-scale events has been going down temperature-wise. 20 years back, assessing basically that the risk was close to zero because nobody was suggesting that we would be heading towards 5 degree plus of global mean surface temperature rise. But the evidence today shows that we are within this 1.5 to 2 degrees Celsius bracket, even in the consensus across the entire climate science community, which is what the IPCC represents. So here we are in very dangerous terrain. What does that imply? Well, it implies, I would argue, that we have to really not rethink risk, but be more clear in how we communicate risk. Risk can be defined in many different ways, but its most simple, basic way, it is the probability of occurrence multiplied by impact. And I think this is something that we have missed out on because we tend to focus too much either on uncertainty ranges related to the likelihood of occurrence, the left side of this equation, or fundamentally on impacts, and particularly impacts of extreme events. If we take impacts to the highest level of severity and talk about global catastrophic risks, this is increasingly well defined. We have centers at Cambridge University, this is a definition from the Global Challenges Foundation, placing a global catastrophic risk as an event or process that puts the risk of lives of humans at 10% of global populations being at risk, or extinction rates of large biomes, and that the geographic reach must be regional to global. So that is like the highest level of red alert we have in the world. 10%, roughly 1 billion people put at risk, regional to global, large-scale extinction events. Well, I would argue that the Earth system risks have reached this level, that we are now facing, on our watch, a global systemic risk level which matches these risks. We are suddenly at this point where we, within our lifetime, cannot exclude the billion-level threat to livelihoods of humans, regional to global impacts that could change the functioning and life support of the entire Earth system, and that we're talking of extinction threats to large-scale functioning of the Earth system. If you add to that the fact that we're heading towards overshoot, this makes the situation even more urgent. We know that within the next 5-10 years, what you see here are the scenarios of the C1, the low overshoot scenarios, and the C2 scenarios of the IPCC. They all hold 1.5 degrees Celsius, but the overshoot ones, not until the end of this century. Scientifically, we at the Potsdam Institute conclude that the blue lines here are no longer possible, so that we basically are inevitably now heading towards overshoot within the next 5-10 years, and we'll have 30-40 years of up to 1.7 to potentially 1.8 degrees Celsius of global mean surface temperature rise before we can come back to 1.5 under the condition that no tipping points are crossed, that we phase out fossil fuels, that we keep the carbon uptake capacity in nature intact, meaning coming back to all safe spaces of all the biosphere boundaries, scale carbon dioxide removal, and finally have a magical transition of the whole agricultural sector from source to sink. Ta-ta. That is what needs to happen to come back to that point by the year 2100. Are we at risk? I would argue yes. So what can we do then with the tipping element systems? Well, this is just a suggestion. Here you have the 16 tipping element systems. I've just tried, basically on my own, let's say, expert elicitation effort, of sequencing them based on likelihood of occurrence, meaning occurrence within the next 25 to 50 years, meaning at a 1.5 degrees Celsius temperature rise. And on the x-axis here is the severity of impact. So high is global catastrophic risk, low is still large risk, but it's not at that 10% global population risk. And basically what you have here is the first category are those that Tim pointed out also that are likely to cross their tipping points already at 1.5 degrees Celsius. They will essentially, with high likelihood happen. It's very difficult to avoid them, and they will have extensive impacts on societies across the world. The big question is this side. Are there now, scientifically, a list of tipping element systems that fulfill the criteria of being at high likelihood of occurrence and reaching the unacceptably high impact of catastrophic risk criteria? And I would argue that this group may actually be coming to that unacceptable level. These are the big ice sheets that Ricarda will be talking more about, the Amazon rainforest that Carlos will be talking about. By the way, here are the top experts in the world. And of course, the AMOC, the whole overturning of heat in the North Atlantic. And here we have experts in the room, like Henk Dijkstra, and I know that my colleague Stefan Ramsdorff is here, and we'll have sessions on this as this week moves along. If this is the case, that these fulfill global catastrophic risk criteria, I would argue or suggest that we in the scientific community need to be clear about that, need to communicate that to the world. Not to scare, not to create passivity, but to encourage more action in the type of action that we saw 2 days ago when Rutte and his team met the NATO club, and they could, over just 24 hours, agree to bump up military spending to 5% of GDP. That is managing risk at the highest level. What if you would have a planetary club that could do what Nick Stern suggested already in 2006, to put 1% of GDP to solve the climate crisis? Wouldn't that be a club to start supporting? I think that is what we would like to see. The IPCC puts the AMOC risk of shutdown to a medium confidence level by the end of this century. Medium confidence means, by the way, 50% chance. The papers on that we've underestimated that risk is very high, as we know. There are a number of publications, and you're all here to discuss this further. And just to close by saying that we've now also decided to step up also the scientific communication on the planetary boundary science to every year do a planetary health check, which is to assess the risks of losing resilience in the Earth system. And this is the 2024 health check. We're preparing the 2025 right now for the New York Climate Week in September. And you see we place the planet outside of the safe operating space in the danger zone of scientific uncertainty, but not yet in the red zone, which means that the window scientifically seems to still be open to turn things around, but boy, is it urgent. Now this lamp is blinking, so I'm finished. Thanks a lot.
To invite up then Ricarda. Am I echoing?
Yeah, thank you very much, Betty, and thanks so much for giving me the opportunity for another deep dive. And I will spend the next 10 minutes to think together with you about two of the systems that Johan has just kind of labeled as one of these unacceptable global catastrophic risk systems. The IPCC said that the likelihood of abrupt and irreversible changes and their impacts increases with higher global warming levels with high confidence. These are two of the so-called slow onset systems. More about that in a moment. They are also undergoing unprecedented change. And this is really change that has never been seen in human history, and even before that. And together, they hold enough ice to raise global sea levels by about 65 meters. So I'm, of course, talking about the two ice sheets on Greenland and Antarctica. And if I wanted to give this talk a title, I would probably call it The Long-Term Legacy of Short-Term Climate Action or Inaction, or in short, Time Matters. So this is also a deep dive about timescales and our thinking of timescales, and how we can come from thinking about intervention times to the long response times of the Earth system. And because the two ice sheets are often called these so-called slow onset systems, I also wanted to remind us that they actually can undergo quite fast and also abrupt change. And so here's just one example of an event that took place several years ago at the Ilulissat Glacier in western Greenland. Many of you may have seen this in the movie Chasing Ice. And this is one of the largest calving events, actually the largest calving event ever recorded on camera. And so we're just gonna kind of together travel to Greenland and see what happened.
I'm on the phone with Jim on one of our regular check-ins. Jim, nothing's happening.
Hey, Jim. It's going well. We had some serious bouts of wind, but other than that, things are fairly well set up here. We've got some continuous time-lapse going.
It's starting, Adam, I think. Adam, it's starting.
Oh, wait, Jim, this is the big piece is starting to calve. Let me call you back.
Call him back.
Okay, bye.
Still going? Yeah, in that V section right there. Holy shit, look at that big bird rolling. All four are running, right?
Yeah. Look at that. You see how, look at the whole thing.
So as these images continue, just a few numbers. So this calving event actually lasted about the duration of this session. And within that time frame, the glacier retreated and parts of the glacier collapsed for several kilometers land inland. And the pieces of ice that you see calving off here, they're about 1,000 meters thick. So this means the pieces of ice that you're seeing shooting up there and turning over, these are actually really large pieces of ice. Actually, there's a quote that I quite like because it helps us to put this into scale with human references. So here, the colleagues actually said that in order to put this into perspective with human references, you can imagine Manhattan. And all of a sudden, all of the buildings in Manhattan start to rumble and to quake, and to peel off and to fall over. So falling over within the matter of basically a bit more than an hour. And I think this just shows that even these kind of regular calving events, sometimes large calving events such as this one, sometimes smaller calving events, but they are occurring more frequently with climate change. And I think it just shows that even the so-called slow onset systems, like the ice sheets, can actually undergo quite abrupt change. So there's potential for abrupt change in both ice sheets. Now the question is, how does this affect the long-term stability? So now we just saw basically a snapshot in time, and the question is, how does that scale up potentially? And this depends on actually a number of amplifying and dampening feedbacks. It's a very complex picture that you can see here, just to give an idea of all the different feedback mechanisms that are at play for the ice sheets, especially in interaction with the atmosphere, the ocean, and the solid Earth. And so what we can do is use our numerical models to try to study the long-term stability of the ice sheets. And this is exactly what we've done here for the Antarctic ice sheet. So what you will see now is basically a thought experiment. We're very slowly increasing the global mean temperature and then looking at the response and recording the response of different parts of the Antarctic ice sheet. So as we're seeing this animation, you can see the global warming level and ice loss on the bottom left there, and then also a map of the changes on the right. And as we can see, there's actually a whole sequence of tipping points for Antarctica, where the first one is around 2 degrees, and we just saw this, that on the very long term, this could lead to a collapse of the West Antarctic ice sheet, mainly driven by ice-ocean interaction. And then as global warming continues, the other marine basins in East Antarctica, for instance, the Wilkes Basin, also start retreating. And with even higher warmer levels, the surface processes become dominant as well. And of course, these are very drastic changes. We have to keep in mind that they, of course, would not happen overnight, but we also have to keep in mind that Antarctica, for as long as humans have been around, has never been ice-free in the past. And these changes are practically irreversible. So we can also do the reverse experiment with our models and basically cool the planet down again. And you see the result here. There's a major difference between the retreat or warming path and the regrowth or cooling path, with as much as 20 meters sea level equivalent between those two curves. And this also means that we would actually have to cool the planet down to temperatures well below present day levels if we wanted to regrow the ice sheet once it's gone. So changes can be abrupt, they are practically irreversible, and also if you look at this global curve and then kind of zoom in, you can see some of the what I would term hidden tipping dynamics, so tipping dynamics on a smaller scale underneath that global curve, for instance here for Antarctica. So if you look at the different ice basins in Antarctica, then you see some basins responding with a rather gradual decline with higher global warming levels, whereas other basins really show abrupt changes, critical threshold behavior, and tipping dynamics. And you can see some examples here, including the Amundsen Sea Basin with Pine Island and Thwaites glaciers, but also, for instance, the Totten region and the Wilkes region. And all of this together, the inertia of the ice sheets, as well as these potential tipping dynamics, actually can lead to long-term so-called committed changes in the Earth system. And this is true for both ice sheets on Greenland and Antarctica, where if we put together the typical projections that we would see, for instance, in the IPCC report, and the committed impacts, then you see a massive difference between those curves. And this is not only true for the two ice sheets, but actually is also the case for other tipping elements in the Earth system as well. And this is what we, among other things, focus on in TIPMIP, the Tipping Point Modeling Intercomparison Project, which is a community-driven effort. Many of you are part of this, where we try to systematically disentangle these tipping dynamics in different parts of the Earth system, from the ice sheets to the permafrost, to the ocean, to the boreal and tropical forests, and many other systems as well. And we're specifically looking at these traits that we just saw for the ice sheets, so abrupt changes, irreversible changes, committed impacts on different time scales and also different spatial scales. And these are some of the key questions that we ask ourselves, and not least the question about the interactions between the different tipping elements. And I'm sure this is something that we will also further discuss in the coming days. And yeah, if you're curious about TIPMIP, there's a whole session dedicated to it here at the conference. But just suffice it to say that we're using the same experimental design for these very different parts of the Earth system to basically stable in both coupled and standalone models these different tipping dynamics. And I just want to summarize some of these aspects about timescales. So time matters for sure, and also timing matters. So we could only see this for the example of the ice sheets for now, but we will dive into other systems in a moment. And we are, of course, dealing with very different intrinsic timescales for instance, the ice sheets compared to the ocean, compared to the Amazon rainforest or the coral reefs. But also, we're dealing with this time clash between the biophysical systems on the one hand side, which can have very long response times, and then the socioeconomic systems on the other side, which can be on very short time scales. So if you think of economic market decisions, for instance, they can be in under a second. And also, because we have tipping dynamics and nonlinearities in the system, this means that we're dealing with a temporal separation of cause and effect, so the difference between the forcing time and the response time. And I've actually experienced this myself. With the committed impacts also comes a deceptive stability of some of these systems over very long timescales. And lastly, the rate of change also becomes decisive for these long-term impacts. And that means that we're kind of facing this dual challenge of, on the one hand side, navigating away from tipping risks and other risks related to anthropogenic climate change, and on the other side, fostering rapid societal change to do this. And of course, this has implications for both international and intergenerational justice. We can only dive into this for a moment here, but basically with tipping dynamics, this also exacerbates already existing inequalities on this planet. And lastly, we saw this with the committed changes from the ice sheets, but the choices and actions implemented in this decade really have impacts now and also for the next thousands of years. With that, thank you very much.
So thank you, Ricarda. So I'd like to invite up Carlos to the lectern.
Thank you very much. Thank you, Tim, for the invitation. You've seen already that the Amazon is very close to a tipping point. And also I want to explain to you what Tim also mentioned, the positive tipping points. And as you know, you've seen, Johan, so it's the Amazon, only global warming would be 3 to 4 degrees, but unfortunately we have land use change. So I will be very, very fast in the first part here. The Amazon forest only exists because the forest exists. The key evolutionary accomplishments: high biodiversity, very efficient recycling of water, very efficient recycling of nutrients, very humid biome, blocks fire spread, very efficient carbon storage and absorption, and highly efficient moisture export beyond the Amazon, the so-called flying rivers. And, photosynthesis for millions of years store 150 to 200 billion tons. And of course, most biomes in the world in the 1990s, the Amazon forest removed 1 to 2 billion tons of carbon dioxide per year. Not anymore. Of course, as well, this evolution, the highest biodiversity in the planet, you can see here, 13% of well-known species of plants, fauna and flora. And also, I don't have much time to tell you, but just to show you, the forest evolved in a way, very close canopy, tremendously efficient recycling of water. About 30 to 40% of rainfall in the Amazon depends on recycling of water. And also, this recycling of water means about 45% of water vapor that enters the Amazon basin from the Atlantic will exit the Amazon to the south, what we call we call flying rivers. So this is very important element to feed rainfall systems south of the Amazon and also in the Andes. So as I said, 45% of that, it's about 200,000 cubic meters per second. And this is very important. My colleague, Marina Irota, she's here. She will tell you the beautiful study that she did showing the importance of maintaining, you see the dark green there, indigenous territories. Just maintaining forests in the indigenous territories in the Brazilian Amazon explains 10 to 30% of rainfall all over that area that you see there in blue. She will tell us much more about that. You see one more important ecosystem service. However, unfortunately, in the 1970s, the military dictatorship in Brazil initially, in the other Amazonian countries later, it started high-level deforestation, degradation, and of course that also with forest fire, and also this interaction with the global warming. So that has led, you see deforestation and fire. Fire has becoming very high, you can see here. Cattle, livestock farming is the main reason. And you see here the deforestation, red, livestock, 90% of the first deforestation in most of the Amazon, but also soybeans and even palm oil. As you know, palm oil is the main driver of deforestation in Indonesia, but also in Brazil a little bit, but it's mostly livestock farming. And you can see here the deforestation in red, to 18% of the whole Amazon is deforested. This is we call arc of deforestation. Arc of deforestation in the south here, from the Atlantic to Bolivia, but also this deforestation in the Andes, Colombia, Ecuador, and Peru. That's the place where the highest biodiversity in the planet. The Amazon has the highest biodiversity within the Amazon. So you see here 18% has been deforested. In the Brazilian Amazon, 23%. But also, forest degradation is increasing a lot. You see here, there are man-made forest degradation, timber extraction, fire, edge effects, but also the extreme droughts that we're having now, they are also degrading a lot. So we have about 17% man-made degradation and 17% extreme drought degradation. 34% of the Amazon forest is degraded. So just to compare a little bit for you, this is the forest, very efficient recycling water. You see here, during the dry season, evapotranspiration 4.5 millimeters a day, and the pasture replacing 1.5 millimeters a day. So much less water recycling. This is one of the main reasons of the challenge of this tipping point. And also there's a maximum temperature, 30 degrees, 35 degrees. So much less water recycling, much drier, hotter dry season in the pasture there. And also the fire is creating a tremendous health problem. More than 150,000 people a year have problems with the air pollution due to the fires. And also, I showed here land use change. Now, I'm just saying also, it's happening all over the world. In the Amazon, before we used to have one severe drought every 20 years, 2 decades. Now, 4 severe droughts in 2 decades, 2005, 10, 15, 16, and a record-breaking drought in the in the Amazon history, sorry, that was this you see here, all these dolphins die in this lake near the Amazon River. The temperature reached 41 degrees, never, the Amazon. So just to say what's going on due to climate change, of course, you can see here record-breaking drought to 2023-2024, a third largest El Nino phenomenon, but also a record-breaking tropical North Atlantic temperature. So those things are happening all over the world, but that's inducing. So basically, what we see here, I just want to show you, studies show only with deforestation, zero climate change exceeding 40% deforestation, you'll go from here to there. Up to 70% of the Amazon will become that open canopy, highly degraded ecosystem. Only 30% will maintain the forest near the Andes because the rainfall is 3 to 5 meters there. If we had zero deforestation, 4 degrees, as you've seen in the other tipping points, but of course, as Johan also showed, if we have deforestation exceeding 20% and warming 2 degrees, we are going to reach the tipping point. We are very, very close to the tipping point. Why? You see, the dry season all over southern Amazon, this graph here, is 4 to 5 weeks in 40 years, 1 week per decade. So it was 3 to 4 months, the dry season, now it's 4 to 5 months. As soon as it reaches 6 months, this is the climate envelope of the tropical savanna, very close. The middle there is the vapor pressure deficit. It's very much drier air because of much less water recycling due to the pasture. And the right one, all those areas in red, this is where tree mortality is increasing tremendously. This is happening. It's not a prediction. And also, a study show, you see here, these 4 points. Luciana Gatti from INPE is making these studies. And you see deforestation, precipitation, temperature, and then the carbon balance, the blue total carbon flux, net biome exchange, what the forest removes, and also the emissions by fire of carbon. And what happens is that why the Amazon is so close to a tipping point? Eastern Amazon, that area there, the forest is losing. It's a carbon source, a carbon source. That's really, it shows that area is very close. That's the area there, Eastern Amazon. You see here, it's almost all positive. The forest is losing carbon, and you see total carbon 2024 due to the fires was a record breaking from 2010. So, and also the planetary boundaries, if we really lose the Amazon, the tipping point, so we are going to release 250 billion tons of CO2. We are going to have the extinction of several thousand tree species. Forest loss will reduce the area for 50 to 70%, a 40% decrease in fresh water, and also massive particulate emissions from wildfires. So just to show we are very close to the tipping point. So let me now go to the positive tipping points. My time is over, but anyway, just very, very quickly. The nature-based solutions for zero deforestation, degradation, fire. Let's get to larger scale forestry restoration, how to create a new social bioeconomy, what we call healthy standing forests and flowing rivers, and also indigenous people and local communities' knowledge. Deforestation reduced in the Amazon to 2023, 2024. And second, the Science Panel for the Amazon, we released COP27, the Arcs of Restoration, to do larger scale restoration in the forest. You can see here, this is the 2 arcs of deforestation. We have to convert them in arcs of restoration, minimum 500,000 square kilometers. It will remove 600 million tons of carbon dioxide per year. Brazil launched at COP28 the Arc of Restoration to restore 24 million hectares from now to 2050. And also we need this new social bioeconomy, healthy standing forests, really how to combine science knowledge with indigenous knowledges, and value addition to forest products, to bioindustrialization. We do not have bioindustrialization. All over the Amazon, there is only 171 biofactories of products. I just want to very quickly to show you. This non-timber forest products, agroforest systems, is much more, the profit is much better, higher, many more people compared to soy and to cattle. So we have to move in that direction. Also, the fourth item is valuing the knowledge of indigenous people and local communities. Look, indigenous people came to the Amazon 14,000 years ago. 11,000 years they were all over the Amazon. Look, they use more than 2,300 biodiverse products, always maintained. And I just want to finish here. A vision for the present. Let's keep minimum 70% up to 80% full protection of the forest, 15-20% agroforest systems for this new bioeconomy, and maximum 10% for regenerative agriculture and mining and urban infrastructure. So this is really the living and sustainable vision for the Amazon. We really have this challenge, but it's possible. It's still possible. So that's what we want to do. As I mentioned, the Amazon is very close to the tipping point. We really have to do all the positive tipping points. Why? Because let's save the Amazon, let's save the Amazonian people, because this is the Amazon we want and the planet wants. Thank you.
Thanks, Carlos. And finally, but last but not least, I'd like to invite David Obura up to the lectern.
Okay, thank you very much. Thanks to the organizers for bringing me here. It's a great privilege for me to come and talk to you about coral reefs. But what I will be doing is trying to connect through the various identities I have, working through coral reefs, through the Earth Commission, and now with IPBES, which I'm the chair of and I was very much involved in the assessments, to try and show how we do what I think all the previous presentations have pointed towards is how do we get to action. And I think the IPBES science framing, I think, is the framing that we need for connecting nature and people. It relates very much to sustainable development, and it scales from global to local levels, and I think that's critically important in dealing with global challenges. So coral reefs, what is the status of coral reefs now? I think people are quite familiar with them. I won't go into the importance. But this is a graph from 2020, a global status report that we did. So the blue lines are the coral cover, average coral cover around the world. You can see dips in that coral cover that align with the red vertical lines, which are the global bleaching events that we've seen during periods of very intense or prolonged warming. And then since 2020, we're conducting an update to this report now. But what has been the recovery from 2019 up until about 2 years ago? And then we've been in the fourth global bleaching event for the last 2 years. It still hasn't ended. Of course, we may not know, since NOAA may not be able to report on that as quickly as it could in the past when we quite get out of it. But of course, the situation for coral reefs is very dire. This is the red list of species from IUCN. The Coral Specialist Group updated this. The end of last year, 44% of coral species are threatened. It used to be 1/3 of coral species. The methodology has changed a bit, so you can't compare directly, but that's quite dire. That's almost 800 species that were assessed there. And then we've also assessed the risk of ecosystem collapse, so tipping points in the coral reef ecosystem. The Planetary Boundaries Framework has really focused very well on coral reefs as one of the biotic systems, the biosphere elements that are close to tipping. We have assessed at regional levels in the Western Indian Ocean, my region. I'm based in Kenya. So all of our ecoregions are threatened with collapse, some critically endangered. We're extending this. Those studies that have been done in the past with slightly different approaches, all the results have been that coral reefs are either vulnerable to critically endangered at the regional level that they operate on. And we're extending this around the world now to see where we are. And this, we look very closely at temperature. Temperature is the variable in the climate and ocean system that we can understand very well. I think all know very well from the IPCC this critical range of 1.5 to 2 degrees Celsius when we go from losing many to almost all coral reefs around the world. In the Global Tipping Points report in 2023, a group of us, many present here, revised this down to 1 to 1.5 degrees Celsius. Of course, we're blowing through 1.5 now. It'll take us another 10 years to go through that average 20-year window that the IPCC uses to define this. But of course, the last few years we know have been super hot. And the reason why is because the surface temperatures in the ocean have shot up in the last few years. And I've been tracking this graph that I put out. I think it's an incredible illustration of what the light display at the beginning showed really well, is that what used to take several decades of warming in the upper ocean took 1 year in 2023. The temperatures shot up and they haven't gone down since then. And it looks like that just projects into the future. We go through these step changes in global temperature, and it doesn't, once it goes up, it fluctuates a little bit, but it doesn't go down again. And every 5 to 7 years, you get a big step up. So the future for coral reefs from a temperature point of view are very dire. Now, but it's not, and then this graphic I want to show from the 2023 report, just illustrating the ocean atmosphere tipping elements, the biotic elements of circled or put blue squares around the ocean ones. And of course, in the biosphere elements, I think that's 8 are ocean-related, 5 terrestrial. So it's a bit of a wake-up to me to see that. And we often think that we have less information on oceans than we do on land. But in this case, of course, we're quite concerned about the state of the ocean systems. One of those is coral reefs. And what the socio-ecological tipping element component of the report really showed to me that it's, while we, of course, in the Earth system, we tend to look at these variables that we have a lot of data on, so temperature or acidification, these sort of single variables that we look at, and we're looking for similar sort of state descriptions for the biosphere. Can we describe the state of the biosphere with single variables, like is there a 1.5 limit for biodiversity we can identify? And each time we try and do that, we don't get there. When you look at the socioeconomic context as well, it gets even more complicated. So from this very simple picture of corals responding to warming of 1.5 degrees Celsius, when you're looking at coral reefs as a tipping element, one, there are many other biological components of coral reefs, but there's even more socioeconomic elements that we need to think about in trying to understand. So what is going to be the impact of coral reefs tipping? But what are the dynamics of that tipping as well? And there's many more social components that we should also be looking at. So, and coming to the framing of this conference and thinking about the session that Johan presented at the beginning in terms of thinking about risk and resilience. Now in coral reefs, we've worked on resilience a lot. A lot of the resilience science has actually come from some of the same scientific community as the Earth system science. And I think it's very useful while resilience is a bit of a difficult thing to pin down, it's actually very conceptually understandable. And I think this idea of eroding resilience is very important. It's much more than just about coral tolerance to temperature rise. And there's so much effort being put into coral restoration, into supercorals, and can we save corals? But it's so much more than that. So this was a study on horizon challenges from 2022 that was put out. And I contributed this fourth element. There were 5 ecosystem elements. This fourth one was about equatorial marine communities becoming sick due to climate migration. So we know that with climate change, species are on the move away from the equators towards the poles. In many temperate systems, there's a lot of grumbling about this tropicalization and species moving in. But actually, those are the saviors of the future. That's what's going to create the ecosystems in the future. And climate migrants should actually be welcomed by systems as they come in. The challenges around the equator, that big, thick blue bar in the ocean around the middle, we looked at this in the IPBES workshop report, because there's no replacement of species. Species are moving out, and there's nowhere warmer for species to come in from. So what's going to happen in those places? But it's more complicated than that, because you also have acidification, deoxygenation, higher pollution, increasing population, governance challenges, and not just that related to temperature, but you also have these other horizon syndromes as well affecting coastal zones at the same time. So we're looking at whole system change in tropical marine systems around the world, not just temperature change that we might be able to breed supercorals to restore reefs with. There's very serious existential and equity crises in inshore tropical coastal systems coming up. And in the position that I'm in now, certainly as the chair of IPBES, I have to be very careful about discouraging investment in research and coral restoration, because we need that research. But are we thinking about the socioeconomic context of what those reefs are going to be? And while, of course, there will be resilient reefs that remain in the future, there'll be beautiful places that many will want to go to. There'll be some restored areas with reefs that will be very valuable to do that. But those are really going to be less than 1 to 5% of the global distribution of reefs, probably, hundredths of a single percentage point in terms of the area of those systems that we can restore and maintain in a warmer world. What happens with the rest? What's going to be that resilient state, that other dip in the system? Will it be a good resilient state where people can live and there'll be economies and so on, or will it be a bad resilient state in which there'll be very little that can be done in those ecosystems? And this is where I think this resilience model that IPBES has developed about how people interact with nature. And here I frame it in the sustainable development context, because this is where we have to follow the stuff, follow the money. Products go from nature into economic systems, the way our economic systems extract those damages nature, and now we also share those benefits increasingly poorly in the global community. So these are single-step interactions that we can have interventions in. This is where we can come to the positive tipping points coming up. And then relating it back to the work that we do in IPBES, so the last 2 assessments that we have done, approved in December, the Nexus assessment essentially looked at complex interlinkages between nature and economy and all the synergies and trade-offs related to those, looking up towards how governance can support those processes. And the transformative change assessment took the complementary perspective. It looked at the value systems and the beliefs that affect the indirect drivers and the decisions that we make that project downwards through our economic activities to how we impact on nature. And I think this is where, in terms of thinking about positive transformations, this is where we really need to think about scaling efforts from local to global levels. I think there's a lot of criticisms about the sustainable development model and the sustainable development goals, but really what they do is provide a system model of how we can plan changes and interventions, and that can be consistent from local to global levels across countries, different value systems, and so on. So long as you buy into the idea that you need to go for positive interlinkages across all of these and address trade-offs. So I guess I'll finish with that because my red light is on. So thank you.
Well, very inspiring talks there. So while you're thinking of your questions, maybe I'll ask the panel one to weigh in a little bit. Some of you have already kind of alluded to it, like Johan, but why or how can we make sure that the G7 or the EU or the UN or whoever devote immense resources now towards preventing tipping points when there are many, many near-term pressing issues that they're dealing with? Who would like to start?
Start, should I? Well, I've kind of shared some of my thoughts, but I think one missing piece, which I think this conference has a golden opportunity to contribute with, is, of course, to shift the narrative, to position catastrophic risks of crossing Earth system regulating tipping points in the context of security, of stability, of health, of peace, fundamentally, of creating conditions for prosperity and equity, not primarily presenting it as it is, of course, fundamentally for many of us. These are environmental challenges. These are about climate stability. But the world outside, I think, needs to understand that these are questions that should be at the UN Security Council. We should have a special planetary security council that devotes itself fully to the risks related to the stability of life support on Earth, not as an environmental issue. I think that's one of these shifts, and that's where I think what you've been encouraging us to do, all of us, Tim, to bring in the positive side of the coin, I think is really important.
Yeah, and I think just to recognize that all of these challenges are, of course, heavily interconnected. So in the Anthropocene, there really is no boundary between climate change, tipping dynamics, questions of governance and polarization, questions of health, human health, and also planetary health. So I think bringing all of these together, and I would even add one more, and that has to do with the timescales. But I think one kind of real shift in our thinking that could be very beneficial is to kind of leave this tragedy of the time horizon and really start thinking a little bit longer term, start thinking about what does this mean for the future generations and bring that into our current decision making. And I think that would really help tremendously in connecting these different issues, but also different solutions.
Carlos?
I just want to add a little bit. As you know, we are having COP30 for the first time in Brazil, in the Amazon. And needless to say, COP30, as all of us, you've seen how close we are to many of these tipping points. The temperature is almost 1.5 degrees warming. So this is so tragic. So we have really to make sure COP30, all countries, except US, sorry, all countries will really do something very important. Johan and myself, we are working in that direction as well. But I would say, for instance, we are finishing a study in Brazil showing that Brazil can get to net zero emissions by 2040, not 2050 like the Paris Agreement, COP26. So I'm just saying how important will be really COP30 to put all countries in the direction of looking for solutions.
David?
Yeah, thanks. So I think my response would be, if I take the nature economy society model as I put it there, is that we've basically, where does money come from? You asked about, or we mentioned the G7 or the G20 are powerful actors. How much money has to go into rebuilding the planetary system? We've basically extracted wealth from nature into economic sectors, which then goes into money, which has been over-extracted. And that finance has to actually come back into nature in order to rebuild the systems, the life support systems that we depend on. So it's basically, in a way, a simple systems model. It's really realizing that short-term needs in terms of employment and growth and so on, they do just take something out of nature that has to be put back later on if you just focus on that. So we need to integrate all of these systems together to really understand the amount of finance that has to go back into rebuilding natural systems, and equity that has to be shared well across societies, across the planet.
Okay, thank you. So questions? We have two people with microphones. Don't be shy. Right here. In the front row here, let's start.
I think amongst the many questions, one would be, why do you think that the Global Security Council is not having this discussion? What are the three things that we all need to walk out of here between now and November to make sure change so that they do?
Yeah, I can start. Well, to begin with, let me just say that as a Swede, I can say proudly that Sweden brought climate into the UN Security Council. That was Margot Wallström as the Minister of Foreign Affairs. She handed it over to Germany, that also tried to bring it into the UN Security Council, but then it kind of faded out. I think there are two issues here, I think, that we've covered already in this panel. I mean, one is Ricarda's point about our inability to handle timescales, that we are so locked into immediate, extreme catastrophes to make it into the UN Security Council. It has to be a war, it has to be a financial crisis, it has to be something very immediate. So changing the whole time scale, understanding that we take responsibility on the long term is critical. But number two, which I think is a challenge to us in this room, is that the uncertainty ranges, the probability and likelihood language makes it possible for policymakers to kick the can down the road all the time. If the world knew with 100% certainty that an AMOC shutdown is equal big risk as an asteroid in a don't look up type situation, I can assure you the world would behave like Meryl Streep in that movie. So it's also, I think, for us to be able to raise the assessment, to speak the language of finance, as you pointed out, David, but also of policy making in the foreign policy offices sitting in the Security Council. So I think we can do more than we are doing today. But admittedly, the world is a very complicated place right now.
Anyone else want to next question. Let's take one more here and then we'll move back there.
Thank you. My name is Bert Ravelli from the Netherlands. Question to the panel, especially to Johan. You mentioned Mark Rutte and the NATO top. That happened, of course, under enormous pressure worldwide, thanks to Putin and Trump. We talked about the Global Security Council. Are we not in need of research, together with you, but also with people from political sciences and governance, towards tipping points in global decision-making? Because that's the problem. I saw in one of the preparatory documents of this conference earlier this year, we don't need more PDFs, we need strong governance, timely and effective action. So how are we going to that process? I mean, we could be sitting here next year or in 2 years with the same question. And again, 2 years gone of this decade, which is quite important for coming into action. So that's the question I have. Tipping points in global decision-making, governance.
You want to say something, Ricarda?
So I think, yeah, as we move through the program, especially tomorrow, I think there are quite a few sessions dedicated, especially to these questions. And I would say we don't only need strong governance, we also need anticipatory governance, or that's part of strong governance. So thinking about how to bring this about, how to do collective decision making under deep uncertainties, so kind of connecting those 2 points, I think is one of the key questions. There's a lot of research going on about this, and I think also there are quite a few projects that are dealing with this as well. So for instance, at the EU level, we've had some workshops and science and policy discussions around these issues. So I think maybe this is a good starting point to keep, yeah, as you say, working together towards some answers on governance, especially.
David?
Yes, if I respond to that a little bit, to the first question as well, and I'm going to channel the transformative change assessment here, which there are some authors in the room as well, so they can answer better than me. So what the authors identified in that assessment was that there are 3 underlying causes of the system that we're in now. And to some extent, the answers we've had sort of assume that the system can make better decisions. Mm-hmm. But one is that the 3 underlying causes are, one are systems of domination of nature and people, while we have value systems that seek to dominate nature, because we see ourselves out, separate from it, and dominate other people, we'll make similar decisions. Second one is inequalities in power, essentially, which are quite related. And then the third is short-term material gain. So our answer from the framing that IPBES has is that we need to have significant values change or consider plural values in our decision-making around the world. And until we do that, we will continue to make the same sorts of decisions. And the decision-making system we have now, the Security Council, the UN system, was designed after the Second World War, and now 70 years later, is it fit for purpose? And of course, many people think not. So we need significant changes in the structures and the values that we use around decision-making to improve that. How do we do that? I suppose by communicating these findings very clearly and effectively, but in ways that point towards positive transformations rather than the disruption and chaos that is sort of emerging in the current system.
Thank you. Question up there.
Hi, I'm Rachel. I'm the climate correspondent for The Economist. Given that a lot of the focus here is on communicating the risks of tipping points appropriately, what do you think that the media gets wrong or right about that, to your mind? Sort of general panel question.
Opening a can of worms.
Yeah, but it's a good question. So
it's a very good question. And I think your colleague Oliver Morton is on the program as well, who, by the way, was the journalist who, on the front page of The Economist, welcomed humanity to the Anthropocene 2011, with a phenomenal piece in The Economist. I say this because my view is that media is getting it really wrong. I mean, seriously wrong. Yeah. And this is, and it's really unfortunate that we're allowing ourselves to have a media landscape that underplays risk, wants to have sound bites from science, not recognizing. I mean, just what Ricarda and well, my fellow panelists here shared. You would just really, really want that to be something that everyone in the world could share. I mean, what we saw here from Carlos on the Amazon basin, I mean, so few people know anything about it. If I would walk down the street in Exeter and ask 100 people, what do you know about 1.5? Nobody would even know what you're talking about. And even if they knew what you were talking about, they would not know that 1.5 degrees Celsius is a big number. That is a risky number. And I think media has a huge responsibility in allowing this still to be an environmental topic, a topic among many other topics, as if it's not something that should frame all political areas in the world. So I think there's much more that needs to be done. Of course, we need to be better at science to step up and engage with media as well.
Any of my other panelists want to comment?
Can I make
Carlos, please.
you know, just to make another comment. We only talk about the climate emergency, but you know, degrading all tropical forests in the world, as we are doing, there is a tremendous risk of epidemics and even pandemics. Science shows perhaps 1 to 2 pandemics per decade. For the first time ever in 500 years since the Europeans came to South America, we have 2 epidemics out of the Amazon, Maiaro fever, Otto-Bliesner fever. Otto-Bliesner fever has contaminated more than 30,000 people. Not only in the Amazon, now it's all over South America. So I'm just saying why the media does not show the risks that we are doing to the planet. In that sense, not only in the climate, global warming emergency, but also the risks of epidemics and pandemics.
And maybe just to add, so I think that the media also can play an incredibly important role in moving these things forward. So thinking of this question of, you know, collective decision making under deep uncertainty, we need the media. We need the media to help us kind of filter through, you know, this array of information that is at our fingertips on the one hand side, but that's also really difficult to dissect. And so I think we cannot overestimate the role of the media in all of this. So I think this is just an important piece of the puzzle as well in avoiding some of these risks and moving rapid societal transformation forward. Thanks.
Thank you. Way in the back there, we're going to go. I don't know. Pick one of them. There's a lot of hands in the back now. Maybe we'll stay back there for a couple.
Just to pick up on the media question and try to link it to the question I had wanted to ask before this, I wonder if part of the problem with covering climate change in the media is that the risk of these tipping points is actually implicitly a critique of the system that we have now. And so even covering climate change and ecological degradation adequately seems almost activist. And I was wondering if the panel could speak about this, the kind of political implications of this scientific research. Some of the most interesting political science research right now is shifting the framing of this problem from managing tons of carbon dioxide or managing emissions to thinking about asset owners and the question of stranded assets and how much money would need to be essentially destroyed if we were actually to phase out fossil fuels and bring our emissions down to net zero and stop extractivism in general. So I'm wondering if you could talk about how to communicate the risks that we're facing in the context of a kind of economic critique that's at least implicit in climate science, and how you navigate that in order to get decision makers on board. Because of course, most decision makers under democracies take their power from encouraging extractivism and economic growth. So, thank you.
David?
Yeah, so I'll try and address that, because that's a primary challenge. So in a body like IPBES, we're an intergovernmental body, we have 150 country members, and we've just approved an assessment report that basically says, you know, the mess in the world is because of decisions, you know, the main governments and corporates have been making over the last 150 years when you look at that. And getting the language so we could have the report adopted was really convoluted. So of course when you look at the summary for policymakers, it's a lot less direct than critiquing the current sort of dominant players, but it is critiquing the current dominant players. How do you communicate that in a way that you can start to shift the decisions? You know, my response on the last question is that the Security Council as currently constituted will not make good decisions about these things because you have to change the design of the Security Council for it to do that. Part of the reason I'm using our conceptual framework in this construct of nature, economy between nature and society, is because those are the individual interactions that actually count. If you follow the material or follow the money, you have to change what happens in those specific interactions. Will the powerful actors in those places make those decisions? I don't know yet, but we have to find ways to communicate that directly in a way that does lead to positive change rather than just, you know, doors closing and conflict and so on. So I don't have an answer to that, but that is the direct challenge. We have to change the dominant system as it is now.
Johan?
Yeah, I'd like to, I mean, you put your finger on something really important here, and I'm not that I want to challenge it, but I just want to give a slightly different perspective, that one of the 9 planetary boundaries is the destruction of the stratospheric ozone layer. And as we know, we solved that by science in the 1970s, the signing of the Montreal Protocol in 1987, solutions were available, and we deviated away from an existential threat to the whole southern hemisphere. And I would argue that on climate, we've reached a Montreal moment on climate change, because the science is settled, policy is an agreement. I mean, the Paris Agreement is a legally binding framework signed by all countries in the world. The US has not yet sneaked out, but which they will. And we have the solutions. And that means that you can, I would argue, within the current economy, transition away from danger. And we know that the fundamental economic policy changes are not dramatic in any way violating with conventional economics. It is essentially about internalizing externalities. I mean, with Sandrine Dixon Declan, we're working on the Earth for All and showing all the inequities and the wealth redistribution that is required for a fair distribution of the remaining ecological space on Earth. But I wouldn't say that one has to collide with some extremist or, let's say, radical economic thinking to be able to start the journey of accelerating away from the danger that we've been raising here on this session. I think it's rather the other way around, that we now need to communicate that not only do we have unacceptably large risks, we have scalable solutions, which leads to a double frustration. You know, we have all the evidence of risk and we have the solutions, and still we're not doing anything. That is a double negative, which we need to communicate much more bravely, not say, look here, solving this will lead to unacceptable losers. I mean, remember the transitions that we've experienced. I don't know if you've seen the documentary on Netflix on BlackBerry, which is quite interesting, how Steve Jobs, you know, basically the day after he showed the first iPhone, BlackBerry collapses, Nokia collapses, Motorola collapses. Did anyone care? Did anyone compensate the Finnish economy for losing in the race? No, we just went on with it because we suddenly had a better outcome. Well, that's what we're seeing with electrification of mobility. It's simply a better outcome. The internal combustion engine is the beginning of the end, period. And I think that is something that also needs to be more bravely communicated. I mean, coming back to the media discussion we had.
Thank you. Oh. So, it's not working.
Hello. We're Exeter College students. I'm Eleanor, I'm 16, and this is Amelia, she's 17. And our question was, have we surpassed any global tipping points? And if and when we do, should we move from mitigation to adaptation, or is there still a point in trying to avoid the consequences?
Good questions.
Yeah. Well, can I?
Carlos?
Yeah, no questions. That there is no way not to move to adaptation. For instance, as you may know, heat waves are record-breaking. They are leading to hundreds of thousands of deaths a year all over the planet. And, you know, not only heat waves, all elements, you know, for instance, in many tropical countries, the extreme heat waves and droughts are reducing agricultural production a lot, all those things. So absolutely you need adaptation, but you have to be careful because of the tipping points. So there are ways, there is no way to adapt if we cross a tipping point. For instance, the Amazon. If we really cross a tipping point of the Amazon, 70% of the Amazon will be highly degraded, but not only that, the Amazon, as I've shown, and my colleague Marina Yorta will show more, the flying rivers keep the rainfall system south of the Amazon, and that's the largest producer of agricultural products in Bolivia and Brazil. So that area will become also semi-arid. That's another tipping point. I did not show because there was only 10 minutes, but there is another tipping point. So I'm saying, you know, we cannot cross tipping points because there will be no way for adaptation.
Ricarda?
Yeah, first of all, thanks for joining us, and I think it's so incredibly important to have your voices here at the Tipping Points Conference as well, especially when we're talking about, you know, the future generations and kind of these committed impacts. And I just want to point out that, of course, we're here very much focused on risks that are posed by tipping dynamics in the Earth system. But at the same time, even if we remove that for a moment, then there are some impacts that we already know are going to happen in the future and that we have basically already kicked off. So just as an example, even if we were able to stop global warming today, then sea levels worldwide would continue to rise for centuries to come. We know that the Arctic will be ice-free in summer sometime around the mid of this century under all of the future projections. We also know that some changes, you know, in the Amazon region will keep occurring, and this is just because of what's already in the system, kind of locked into the dynamics. So I think when we think of these committed impacts, we immediately have to think both of mitigation as well as adaptation. So there's not one without the other. And so bringing this kind of thinking into our decision making, especially for you and for the future generations, I think is incredibly important.
And just a small compliment, because in a way you touch on that I think it's fair to say that if you brought, say, a significant group of scientists together, the conclusion is that the answer is no, we've not passed a planetary tipping point. So we still have room for maneuvering. There still is a window open to transition back into what I call today a manageable state of the Earth system. I think what David showed is probably, you know, in a way, the first kid on the block at risk, the tropical coral reef systems. They are very close. The Amazon rainforest, also very close, but they're not there yet. Arctic summer ice is definitely there. And then there's a lot of scientific papers showing that, in addition, several may have crossed or is close to cross, but we're certainly not at an Earth system tipping point. The Earth system remains still remarkably resilient and buffering the stress caused by our unsustainable pressures.
And maybe a final thought on this. Even if we cross a tipping point, the science also shows that it still matters very much by how much and for how long. So if temperatures are beyond some critical threshold, then still every tenth of a degree matters in terms of the impacts and kind of knock-on effects on this as well. So again, both mitigation and adaptation matter also in this context.
And if I can add to that too, to our chair. So I think it's also a false choice that's presented between mitigation and adaptation. If you accept the notion of the full connection between nature, economy, and society from local to global levels, we need both mitigation and adaptation and loss and damage at this point in the climate sense, because we have gone beyond sort of dangerous and unjust levels of change in certain parts of the world. So if the decision-making systems truly understand the interconnections of the system, then they would put money into all of those things because they need to be redressed rather than into other options that may be there that are much more narrowly framed around economic growth or profits and so on.
So we're getting close to the end, and firsthand I saw over on this side. This may be our last question, or maybe not. But two over here. Okay.
Thanks, everyone. Can you hear me? I am Sanjay Rajan, affiliated with the Earth Law Center. My question was regarding positive tipping points and in the social context. Do you think in terms of Earth jurisprudence, rights of nature, we are at a point to bring those discussions, especially you folks are involved with Earth Commission as well. So I'm curious if you are there in terms of social tipping points, that we think in terms of rights of nature. Nature has a seat at the table in terms of business, policies, and everything else. That fundamentally it's not, as David said, humans over nature, but humans are part of nature. Are we there yet in terms of ecocentricity or no? Thanks.
Sure, I can answer very briefly on that. So I think we're getting there because those concepts, of course, in the global discourse now, we're of course not there in terms of the true representation, decisions being made. As a natural scientist, I'm not sure if we need, do we need, Convention on the Rights of Nature? I think we just need to understand the whole system and make decisions so we're not undermining nature in the interests of profit for certain individuals, because the system model needs all of those parts to be in balance.
Carlos?
Yeah, just compliment. You've seen, David show the potential for renewable energies. Tremendous potential. The scale is still very slow. But there is another big benefit. As you know, most of the urban air pollution in the world is burning fossil fuels. Air pollution in the world, urban air pollution, leads to 6 to 7 million deaths a year. So that's another thing. Why we don't really completely stop fossil fuels from the climate emergence, but also we improve tremendously the health of billions of people.
So I apologize to all the hands raised, but I see Hattie there, so I guess I'm supposed to. It's hard to make any closing comments after all this, so, because this has been a great panel and a great audience and all the hands and interest in this, and hopefully over the next few days you can either chat with the panelists here over break or lunch or go to some of the other sessions. So I think I'll leave it at that. I had a statement here, but I think, no, we don't really, we've addressed it all. Well, I'll read it anyway. I thought of this early because Hattie's, yeah, please. So, because we've kind of already addressed this, but you can think about it more. So how our climate policy recommendations change or still need to be changed as we learn more about the existence of tipping points as we did today and the urgency to address them. So I'll leave you with that, and thank you. This was a great first plenary session. I had the privilege to be part of it in a small way.
Yeah, thanks all the panelists. Thank you, Bette, for chairing that. Brilliant. Two more things from me before I let you out for the tea break. I think Carlos rightly brought up COP30 coming in Brazil later in the year, and I wanted to emphasize as we get into the final part of the conference on Thursday, we'll really sharpen our focus to the bridge we're building from this conference to COP30. We're delighted that we've got Tulio Andrade here. He's the Chief Strategy and Alignment Officer for the COP30 presidency with his team. You'll see him probably on Thursday, but we're very much going to take the lessons from this conference through to support all efforts at COP30. And that's not just about top-down governance. If you've looked at what the presidency is promoting, they're also promoting a whole coordinated, catalyzing, bottom-up civil society action on positive tipping points. And the final thing for me just is to remind you that after the joys of tea break, which might even have, does it have scones, Sawaji? I don't know. It might do. Cake, even better. After the joys of tea and cake, in a very British and Devonian way, you get your choice of whether you want to indulge in one of the research sessions or one of the more action workshops. You can see that if you want to delve deeper in the Earth system, tipping points and risks, there's great opportunities for that. If you want to go straight into the governments there, or if you want to cheer yourself up and get into the positive tipping points, we've got a bunch of sessions on that. If you're stuck with where places are, there are some quite helpful signposts, but also go back to the registration desk or grab someone like me. I know where everything is, honest. Thanks again to a fantastic first panel. Have a great break. See you later.